Hi friends, welcome to the data structures tutorials. My name is Meena. We'll be going through different data structures and different operations that can be done with them. Let's start with trees. Trees is a very widely used data structures. They are widely used not only in practical applications, but also in interview questions. A lot of questions will be based on trees, traversing, how to traverse trees, and such stuff. Okay. So what are trees? Okay. It's basically like how you see a real life tree. It's a tree with branches and leaves, right? One branch can have more further sub branches. Okay. And those branch in turn can have sub branches. So that's the core structure of a tree. Okay. Different parts of trees, okay, or a different components of trees are following. Nodes, okay, that forms the basis of the tree. Okay. Here, each one is a node. Okay. One node can have some other nodes like 0 or multiple nodes underneath them. Like say, for example, A has B and C under them, right? B can further have other nodes in them. Like B has D and E as child nodes, right? A and B, A and C are connected by what are known as edges. Okay. In certain situations, edges can have weights. Okay. Parent-child relationship between nodes. Okay. Like A is a parent of B and C. B is a parent of D and E. C is a parent of F. There is also a concept of subtree. Like say, for example, if you take B, D, and E, it's a subtree. Like it's a tree in itself, right? Right? Like how branches have sub-branches, like that. A tree can have multiple subtrees in it. C and F also form a tree. Only thing, it's not a binary tree. Okay? So, yeah. Today we are going to talk about binary trees. Binary trees are specific type of trees. They are most commonly used in different applications, and it has one unique feature. A binary tree can have one or at the most two child nodes. Okay, so there are two childs, like the node on the left is the left child, the node on the right is a right child. All right, today we are going to learn, today's lecture is focused on traversal. Okay, like how do we traverse the tree? How do we go from top to bottom? Okay, so we start from the root and then make our way down. There are three different ways that we can go down, like go down and read the value in every node or do certain operations with a node. There are three different ways. Today, we're going to learn about in-order traversal. Okay, so here is a code. You can see this, each node, okay, right? One node is made up of some other nodes. So see, one node, it could have a value and it has two subnodes, okay, like a left node and a right node. It's composed of certain nodes. Now, again, it's not necessarily that every tree node will have a left node and a right node, okay? In addition, it could also have edges and the weights of the edges, okay? Here is the constructor. But for today's purpose, we are going to ignore the edges and the weights because we are not focusing on that. We are only focusing on how to go from root to the leaf, okay? And that too in a method called as in-order traversal. So here is the demo. So this is what we are going to do for in-order traversal. First, traverse the left subtree recursively, like go on traveling down, 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 down. Okay. First, until we have reached all the way down. Now there are no furthermore nodes underneath F. Okay. Then we go back on the top, the current node, then come right, then go back to the parent, then come to the right. Now off the right, again we go to the left. Then we go to the parent, and then we go to the right node. This is in order traversal, and we are going to use recursion to call it because it makes it very, very simple. Okay, so this is the basic check that if the root is null, just return, right? You don't want to get null pointer exceptions. Now here it is. It's very simple. You recursively call the same function. First pass the root.left. Once the root.left is done, it'll come to the current node, it'll print the value, and then you pass the right node. See, it's as simple as that. It'll go on calling root.left until the left is null. Okay, so when it's null, it's going to return, and then it's going to go to the parent. Okay, so here it is. So we are constructing this tree. So see here, we start with the root, which is 4. Then we go create subnodes. Okay, here, all. So this is nothing but just a construction. Okay, so left of left, right of left, left of right. Okay, right of right. Okay, this is right of right. This is left of right, because left and right are basically on what sides they are. Okay, and then we call nothing but just that static method. Okay, and we pass the root, which is value, and what we expect is it to print 1, 2, 1, 2, 3, 4, 5, 6, and 7. That's the traversal. Okay, so let's run the code. I'm using IntelliJ. Okay, there it is. 1, 2, 3, 4, 5, 6, right? Okay, so one more time, just a recap of what we did. We learned about what is a tree, the data structure, which is a node with its children. Okay, the nodes which do not have any children are called as leaves. Okay, different concept, parent-child relationships, edges, the height of the tree. The height of the tree is nothing but how many depths you have to go, how many levels it has. Okay, then we defined a tree node class, which has its value and a pointer to its left and a pointer to its right. This is just a constructor, which we pass the value and initialize both left and right with null. In the demo, okay. Then this is the in-order traversal. First, we traverse entirely to the left. Base case, when the root is null, you return. In recursion, it's necessary that you always have a base case. Then you print the value, and then you traverse the whole right tree. This was just a construction of the tree where you initialize everything with a value and then print it out. Okay. All right. So that is it. Thank you all for joining. Okay. See you all again in the next lecture with some new concepts. Take care. Bye.